Hi everyone, imagine you are at a four-way intersection where every car is stuck because no one is willing to move first. That's exactly what happens in an operating system when a deadlock occurs. In this video, we'll break down what a deadlock is, why it happens, and how operating system handle these tricky situations. Let's see about deadlock in operating system. Now, introduction. This presentation explores the concept of deadlocks in operating system, including definition, causes, detection, methods, prevention, strategies, and resolution techniques. Understanding deadlocks is crucial in managing system resources effectively and ensuring smooth operation. First, we see definitions. Now we see about the deadlock definition. What is deadlock? A deadlock is a situation in computing where two or more processes are unable to proceed because each is waiting for the other to release resources. This result is in a standstill as none of the process can continue their task without the needed resources that are being held by the others. Next, characteristics of deadlocks. Deadlocks have four necessary conditions: mutual exclusions, hold and wait, no prevention, and circular wait. Understanding these conditions helps identify potential deadlock and develop strategies to prevent or resolve them. Next, we see importance in operating system. Deadlocks are critical to understand as they can significantly affect system reliability and performance. Recognizing and managing deadlock is essential for maintaining system efficiency and ensuring that process can complete their task without identified delays. Next, causes. We can see the causes of deadlocks. Resources allocations. The resources allocation is an operating system or assigned to process based on availability and requirements. Improper resources allocations can lead to situations where process hold resources while waiting for others, creating a deadlock. And competition for resources. When multiple processes compete for limited resources, it is possible for them to end up waiting infinitely for resources held by each other. This competition is primary causes of deadlocks in multitasking environments. The next, we see circular wait condition. A circular wait condition occurs when there is a closed loop of process where each process is waiting for on the next one in the loop or to release the resources. This is a situation is a classic setup for a deadlock. The next, we see detection of deadlocks. The deadlock detection methods. To detect deadlocks, operating system utilize algorithms and resources allocation graph. These methods can help identify when processes are in deadlock, state and initiative recovery protocols to resolve these situations. Next, resources allocation graph. The resources allocation graph visually represents the allocation of resources to process and can be used to detect deadlocks. If cycles are detected in such a graph, it indicates a potential deadlock present in the system. Now we see system status and deadlocks. Understanding the various states of a system helps in identifying deadlocks. A through analysis of a system states can aid in timely detection and prevention strategies to avoid deadlocks. Deadlock detection algorithms. Deadlock detection algorithms are crucial for identifying deadlocks in systems. In common methods include the wait for graph approach and the resources allocation graph method. These algorithms systematically check for cycles in the resources and process graph to determine if deadlock exists, allowing the system to intervene when necessary. The resources allocation graph. Resources allocation graph or visual representation of the resources held by process and the requests made by them. In such graph, processes are depicted as nodes and directed edges indicated resources. Allocation and request deducting cycles in this graph helps identify potential deadlocks, promoting actions to resolve them. System states and deadlocks. In different system states, such as running, waiting, and blocked, are integral to understanding how deadlocks occur. By analyzing the transition between these states, system administrators can identify deadlocks. Recognizing patterns of process behavior and resources usage is essential for effective deadlocks detection and resolution strategies. Next, we see preventions. Resources hierarchy. Implementing a resources hierarchy can prevent deadlocks by ensuring that resources are acquiring in a predefined order. By enforcing this order, the changes of circular weight conditions are minimized, thus reducing the likelihood of deadlocks occurring within the system. Avoiding circular weight. To prevent circular weight, a system can implement strategies such as assigning a total ordering to resources and ensuring that process request resources. In this order, this approach minimizes the changes of deadlock as it distributes the circular weight condition necessary for them to occur. Next, request and hold strategies. Request and hold strategies involve limiting how process can acquire resources. One effective approach is to require process to request all resources at once before execution begins or to release all held resources if they cannot require the remaining needed resources. This strategy helps in eliminating the circular voids.